Okay, folks, 2 more lessons in this unit. And today we're going to talk about geometric sequences. Geometric sequences are a little bit different than arithmetic sequences. They follow a different kind of pattern. So we will find, that's the goal today, is to figure out what is a geometric sequence and how does it work. So make sure you have your pencil, your notebook. I shouldn't have to harp on this again. We've already had a notebook quiz, but make sure you have your specific notebook. Graphing calculator will be handy as well. All right. So what is a geometric sequence and where are the patterns for geometric sequence? So first of all, we're going to talk about the recursive form of a geometric sequence. Now, a geometric sequence, sorry, we're going to go back. With the arithmetic sequence, we have what's called the common difference. In geometric sequence, we have what's called a common ratio. Arithmetic sequences move up in a pattern by the same number, by adding. Okay, and a geometric sequence, we're still moving by the same number, but we're actually multiplying to get to the next number. So, for example, if I had a geometric sequence with a common ratio of, say, 5, I would go, when I started with 2, my next one would be 10, my next one would be 50, my next one would be 250. Okay, these move very quickly up into the big numbers. So the recursive form of a geometric sequence, we take un. Okay, remember, recursive is about finding the number right before it, and we multiply it by r. Okay, that's how we get the very next sequence. All right. In an explicit form, this is one we use more commonly. You will take u1 and you will multiply it by r to the n minus 1 power. That is how we get that. The next one. Partial sums, we'll talk about that when we get there. I think I put this on here, but I don't think we're actually doing partial sums. So here we go. Here's example 1. It says the first term is u1 and the common ratio r of the geometric sequence is given. Find the 6th term, the recursive and the explicit formula. So let's look at those really quick. Sorry, I have the wrong notes I'm looking at too. Okay, so my recursive form is un equals 2 times un minus. Okay, so we notice that in this case, we really, for the recursive function, we say u1 equals 5, and then un is, everything is dependent on whatever the term before it is. So that's the recursive, super easy. Explicit, again, pretty basic. Un equals u1, which is 5, times the common ratio, which is 2, to the n minus 1 power. And that's my formula. Now to find the 6th term, okay, we're going to go u6 equals 5 times 2 to the 5th, okay, which is 5 times 32, which is 860. Very easy, very easy. Okay, moving on. Here's your practice one. Go ahead and try this one. Now, this one's kind of, you actually have to think a little bit. This is one where you're going to have to do more. So what the last example is, but you should be able to. So, go ahead and pause, do the problem, and here's your solution. All right, partial sums. We are getting there. Oh, shoot. Let's go back to the formula. For some reason, I was thinking we weren't doing those today. And usually, I like the formulas on the page. Okay. So the good news is there's only 2 examples today. So we only have 2 practice problems. So here's our partial sums. This is a really nasty formula. I'm not crazy about it. But if you're doing sums, it's un equals u1 times 1 minus r to the k over 1 minus r. So let's go ahead and... Oh, my power is going to go out here soon. So I need to get this video done. Okay. Let's see if I can remember this off the top of my head. All right, so if we're going from k equals 1 to 6, actually I should have this problem over. And it's u1 times 1 minus r to the 6th power over 1 minus r. Okay, and this is where you calculator kind of takes over. I'll do some steps with you. 5 times 1 over, we can do this all in one calculator and one stuff though. 1 minus a half. 5. Then I did that whole stuff. Then I get 63 over 64 over 1/2 times 5. And I end up with 63 over 60. Now there might be a mistake in here. And the reason I say that was I did this problem before, and I don't know that I multiplied by 5. I did that all in a calculator. I don't have it written down. I don't have my calculator in front of me. And my computer is about to die, and I don't want to record this video. So I'm going to assume that's the right answer. You can come and tell me tomorrow if it is or not. But so let's move on really quick. It's really the formula. Make sure you have the formula. So here's practice 2. Again, a little bit different than the example that I gave you. Go back to your formulas and see if you can find and make some connections there. Here's your solution. All right. That's it. There's only 2 problems today, so I will see you tomorrow, and we will do some more problems later.